Good idea. Alright.
Okay, if everyone is comfortable, I'll make a start. Okay, so the way we pronounce the word of ESO is we've called our project Xspacious. And the idea is you explore your space, your statistical space. So the Smart Cities app the Smart City Challenge is all about how you can take local data sets, say like from the census or governmental health records, and correlate these with meteorological and type data record sets, such as the examples of the Birmingham Climate Lab. So Kat Muller, who's done that, she essentially what she wanted to do originally was put a thermometer on the roof of every school to measure just local air temperature and try and have some sort of engagement with school kids, because the background is in those sort of areas. So from there, she managed to actually get a NERC grant where instead of some very cheap thermometers, she actually got some nice bits of kit. And anyone who's followed it over the last 6 months or so can actually see she's actually had quite a large impact with, I think, 3 publications which were submitted January this year on a variety of different topics and outreach to some of the science that come from it. So the idea is, how can we, what's the next step from? So this is a nice introductory how we can do small-scale studies or local-scale studies, and you can get the public involved as well with your site. So where can we go? So this is what Xspacious is all about. So what Xspacious is going to be is a web-based augmented reality app. Okay, this allows the user to explore and engage with the social, economic, and environmental data within their local environment. Okay, so users select between various different data sets. So temperature, rainfall, sort of rates of death, for instance, or household income, and they can use these to look for correlations and patterns within the data. So it's a medium for people who want to look at interdisciplinary data sets. It sort of creates a starting point for people to start looking in between these disciplines and see where they can actually go from there. And the other part of this is the meteorological data, which is collected as part of a low cost. Okay, I put that in inverted brackets because low cost is a relative scale depending on your needs. But a low cost sensor network, which is supported by these auxiliary data sets, and these data sets, again, I would just say that this could be the census, or they could be other universities or local authorities who contribute to the actual program itself. So why do we want to bother? Okay, so climatological issues such as air quality, have a direct impact on health. So 12 to 24,000 people a year die early in the UK due to air quality issues alone. Okay? Luckily in Leicester here we have some of the worst air quality in the UK, so we can sort of sit here happily and go, we're a perfect case study for these sort of things. But with our novel exploration data sets such as this, we can then start to allow them to understand some of the key issues around sort of the social and economic environmental points, such as people who are living in some of the more deprived areas. Are they situated near the motorway, and do they have the wind blowing in such a way that they get all the bad air from the motorway? They're packed into tight houses so that the actual environment they live in stays hotter in the evening, so they don't cool down as properly, which puts more stress on the heart, and other things like this. And then you can then go, actually, you can start to look like poorer people here. They get a bit of a bum deal. And then you can start to look at strategies to make, living there more pleasant, essentially. So, how is that approach? We've got a two-prong approach. So, static sensors. Okay, so there's a variety of local sensors you can put, and you can quite easily now network these things together with off-the-shelf components. And the limiting factor here is primary resources. So, if you're doing this in conjunction with a local authority, it might be a case of if they say we're going to pay for the sensors and put them up, and they have £20,000, you can actually have a nice array of electrochemical sensors that can look at air quality. At the moment, the only thing that measures air quality inside the city ourselves is by the city, Leicester City buildings, and is actually inside the little quad bit. So it's not exactly a representative value for pollution values within the city. So by spreading these out with other sensors, so temperature and humidity sensor, we're talking about pennies here. Electrochemical sensors, hundreds of pounds. You stick a Wi-Fi dongle on that, and with a simple bit of software you can network these all together, and the more you put into it, the higher impact you can have. as we don't really live in an ideal world, we're never going to have the network we really want unless someone really stumps up. So the second approach is crowdsourcing. So utilising social media such as Twitter, you can pose a question and go, what's the temperature where you are today? And people, by using a hashtag, can basically say, I am at latitude, longitude, which then get off their phone, and the temperature is X. Or you can say, where do you live and how old are you? You can pose any of these questions, and via social media you can then collect them on Twitter, and then that's one source. A second source is actual through the app itself. So, which we will demonstrate a bit, is you can have take a measurement buttons. So again, people who are interacting with the app can contribute while they're doing it. So the idea is to allow people to contribute in as many ways as possible. And this isn't just public. So again, this is if you have a university who say we have a nice, time series of data from here to one source point, but we'd like to contribute, so they can upload it as well. So it's this big community science which tries to draw everybody together rather than put people into little houses or something. There we go. So behind the scenes, what's going on while people are sending all this data? So it's all uploaded to a common repository in a common format, which will be outlined in some sort of user documentation, and which is .csv for anyone who's familiar. And a script in the same way would go onto Twitter and extract all the data and put it into the same format. This data can then all be interpolated onto a common grid for the area and then stacked into a data stack for ready to use. So the idea is it's all fairly automated and not a high barrier to actually get these things done technology-wise. So in terms of output, so when we say scatter plots, we're not talking your simple X-ray scatter plots. You can have a map which you then hover over, and it gives you certain values or statistics about where you are. Other things, so you can have a correlation of your data. So on here we have an artificial pollution index we've created for the city, and then we have poor health levels which come from the sensors. And as we can see, in Birstall, where it seems to be very horrible for people who live there, they actually have poor health. And this is the sort of example we're trying to give where, by putting these things together, some correlations will be obvious, but others might not be so. And they might be the hinge point on, the key to trying to solve these problems. So finally, I'm going to hand over, that's not me, and I'm going to give you a demo of what we've actually created this week. So either of them, you want to go first?
Well, I was working on a data visualization, web-based data visualization. So this is a scatter plot done in processes of population density. You can see, for example, here population density is quite high. So the bigger the dot, the more dense it is. Down here in like Stonygate, we did that as dense. And then I'll just show you another parameter, which is annual gas consumption. You see here where we saw very high population density, the gas consumption was low. Down here in Stonygate, where the population density was low, we have a very high gas consumption. So by looking at these plots, you can maybe see some not too surprising results, but it is helpful to actually see the data. And if you mouse over these, you can get the so it's interactive as well.
So this was developed this weekend?
These past 2 days. Yeah. And this is from local census data, available from the council.
Okay, and the other visualization tool we worked on was an interactive app, which means that you can not only visualize the data around you, but it also provides a means to contribute yourself to that data set. So this is actually running live now. We've got a web server over there running on my laptop, and this is a mobile device, which I need to unlock. And as I rotate it, so if I look in different directions, you can see the intensity of this red area here will change depending on where I'm looking. I'm not sure if we can get this to, it won't face you, but if it's facing north, it shows a symbol of a tree. Does someone want to rotate that around so you can, if you north is roughly over there. Oops. So keep going that way. So you can show pictorial information as well with this. So any of those data sets can be visualized like this, and the data that the web server is serving up to this is indexed by my location. So as I move around, it feeds different data into this app. There's also a log new reading button. Oops. Press my log new reading button. So if, for example, I were measuring temperature, I could type the temperature into here, click OK, and if anyone wants to prove that I'm not lying, there's a link to a text file on my laptop. The number I just entered was 21. If you double click on that text file, you'll see at the very end, yes, yeah. There's in the middle there should be a shortcut to a text file.
The one in the middle?
Yeah. So right at the end of that string should be the number 21 as being the measurement that was uploaded, along with my GPS coordinates of where I was. So you can actually contribute to the data set in that way. And I think that's us pretty much done.
Thank you.